Now let's look at equivalent fractions. Equivalent fractions are fractions that have different denominators and different numerators, but are still equal to one another. So I'm going to use this rectangle that's divided into two parts as an example. If I were to ask you to write the shaded part of this rectangle in terms of a fraction, my whole would be the two parts that it's divided up into, and one of those two parts is shaded. Now, if I chose to further divide this rectangle, I've changed my denominator, but I've also changed my numerator. Now I have 4 parts total, and 2 of them are shaded. Okay. Now I've changed my denominator again, but I've also changed my numerator. I'm not changing the fact that this is half of the whole box. But every time I add a new line and organize it slightly differently, my denominator changes, and my numerator does as well. And if I made one more change to have a total of 16 boxes, 8 of them are shaded. Now, we can see a pattern here. Every time I changed the number of boxes, I purposely increased the number of divisions in here by 2. So 2 times 2 give me 4. And we see that the relationship between my numerator is the same from the original numerator. I multiplied my denominator by 2, and then I multiplied my numerator as well. So as long as we're multiplying our denominator and our numerator by the same factor, I'm not changing the value of my fraction. Same thing here. When I changed the number of divisions from 4 to 8, I multiplied my 4 by 2 to get 8. And then if I multiply this numerator, I'll get 4. So we see here there's a mathematical pattern. And this is true for any set of fractions. If you multiply the denominator and the numerator by the same value or by the same factor, you're not changing the value of the fraction. You're just changing the way you express it. And we'll see in a little bit that it's very important to be able to get a certain denominator. We may need to change the denominator in some circumstances, but we don't want to change the value of our fraction. Now, we'll get to this a little bit later, but we see that we can multiply our numerator and our denominator by the same factor, and it doesn't change the value, it just changes how we're expressing it. Well, we can do the opposite of multiplication, which is division. And as long as we are dividing by the same factor in the numerator and the denominator, I'm not going to change the value of the overall fraction. So 8 over 16 we know is 1/2. 8 is half of 16. And if I divide the numerator and the denominator by the same value, I don't change the value of the fraction. It's still a half. Whether it's 2/4 or 4/8 or 8/16, it's still a half. And we'll see later that there are different reasons for wanting to express a fraction with different denominators. Now what I've done right here, by reducing my numerator and my denominator to smaller numbers, this is what's known as simplifying, and you may have seen this term, reduce, because we're reducing our numbers to smaller numbers. And we'll look at this in more detail in just a little bit. But before we go on to simplification, I want to look at equivalent fractions in a little bit more detail. Okay, equivalent fractions have equal cross products. Okay, so what is a cross product? Well, let me show you the type of problem that you may be given. You may be given something like this, and I've put my question mark above this equal sign. Are these two fractions equivalent to one another? If they are, then what's known as their cross products are equal to one another. Now, cross products can only occur over an equal sign. It's very, very important to remember this. We're going to look at multiplication of fractions, and many times people get this confused. This is not multiplying fractions. This is checking to see if two fractions are equal or equivalent. And the cross product must occur over an equal sign. So let's look to see if the cross products are equal. By cross products, what I do is I just make an X, and the two values that are connected, the numerator of this fraction and the denominator of the other, denominator, numerator, these two are connected, and that's what I multiply. So 4 times 9, is this a true statement? And we see that it is. So yes, these two fractions are equivalent. So this is a relatively simple way to determine if two fractions are equivalent to one another. We look at their cross products and see if they're equal.